Welcome everyone to Surface Mount Device Soldering with Evan and I, and this is a virtual workshop, the first one of the quarter, which is very interesting. We'll get through it. All right. So just a little bit of a schedule. We're going to go through a background, and we're going to go step by step and some really good tips for how to perform the soldering with different tools. There's a couple different strategies to do SMD soldering, and then we're going to introduce this hands-on project, and we're just not actually going to do it, but we're just going to see like that's the potential. If we were to have an in-person workshop, this is what we would be working on with SMD soldering. So yeah, we're just gonna go ahead, and then Evan, guess you could introduce a little bit of a background.
Okay, so there's two main types of soldering. There's through-hole mounting and surface mounting. So basically through-hole mounting would be using via type connections to have through-hole components. So basically they'll go through all layers of your board and come out the other side. So you have to solder them in to make the metal contacts connect with the metal on there. So they provide good mechanical bonding since the bonds are larger, more surface area, but they require the drilling of holes on the PCB, which limits the available routing area. So you don't have as much space to do them. So it's good for prototyping and exchanging parts. So say you need to take out a certain resistor or a component. It's a lot easier to take that out than to take out a surface mount component. Surface mount components can be made much smaller, so you can have smaller, denser PCBs, which is one of the advantages. They're also more commonplace in industry where a lot of these processes are sort of automated or they're very smooth. And then they're also, they can be mounted on both sides of the board as well. Well, they can be in both cases as well, but you have more choice in area because it only takes up one side.
Yeah, that's right. And just a little bit more background, I guess, for SMD soldering, primarily in terms of IEEE projects, they're going to be used for more of the advanced projects, so aircopter and micromounts. But I think Ops is starting to implement some more um, SMD soldering. So we're going to see some of that. So it's going to be useful in a lot of different projects. All right, moving on. So SMD has a bunch of standardized sizes. So you can see a lot of the times if you've ordered parts, you'll see a bunch of different package sizes that refer to like the physical footprint of these devices that you're trying to solder on. So they're given a bunch of codes. For example, like LEDs and resistors, they use metric 0603 or something that you've heard really common, and it's just like a short name for the actual size. So like basically each component will have a bunch of codes that will detail the outline or the footprint of the device. So what's really cool is that TI actually gave us this, and if it was a real workshop in real person, we'll have this as a prize, but this is like an example of some of the sizes. So they give a bunch of different packages and footprints for a lot of SMD devices, and yeah, there's all on here. So you can see there's a couple SOT, small outline transistor, and SOD are pretty common as well. Yeah.
Oh, and just for reference, like if you're looking at something, capacitors and resistors, they have like the 0603 package that stands for basically the sizing of it. So usually you'll want to do a size that you'll be able to hand solder for the IEEE projects. So when picking your components, you don't really want to go down into like the 04, 02 range. You want to try and stick with something you'll be able to pick up with tweezers in place easily.
Yep. Okay. So next up, we have an introduction of the various SMD soldering methods. It's pretty straightforward. So a lot of you guys are used to using an iron, and that's how IEEE has done it in the past, which is pretty tedious, but it's very simple to teach and not very advanced. And we're gonna also be introducing a bunch of other methods, including the heat gun. And recently, IEEE has gotten a reflow oven for SMD soldering. So it's in the lab right now, which is really cool. So when you guys have access to the lab, Evan and I have kind of, and a couple of other project leads have done a little bit of usage of the oven, so we can teach you that too. But this is just like a little instruction to use it.
Oh, do you want to play the video, or do you rather just explain the steps first?
I think we have a couple of pictures in the future for some step by step, but this is just like another reference, I guess. So this is just kind of like lists out each step. It's pretty straightforward. We're just gonna go into it more with a couple of GIFs later on, so I think we'll cover the same exact thing. But basically, here are the steps, and there's a little YouTube video link that details the exact spot of each step, so you guys can like click along and then follow. Yeah. So the first step. So this is just soldering with an iron. So it's pretty straightforward. If you guys have done through-hole soldering, this is pretty much very similar. So the concept of tinning will be also used here, where basically you just take a little bit of solder and then you put you tin one of the pads. So on that PCB, you'll have various pads that kind of like are in this that detail the connections from your board to your device, and so the tinning aspect will allow you to um, be able to place the component on there and then get like a starting point, like a little hold for the SMD device, and then you'll be able to solder the rest of the pins later. So you'll see that.
Yeah.
Yeah.
So basically, is you'll tin one of the pads, and then you'll place the component. So you'll tin the pad, take the component, heat up the solder again, and place the component while the solder's hot. Then remove the soldering iron so that it sticks in place on the pad. So then you already have one pad, and you won't have to hold it in place anymore, and you can solder the other pins for it.
Exactly. All right, so next up you'll see here that we're placing the device on with tweezers, so it's like a really small scale. And then you can see we're just doing that single pad. And then you can also see that some of the other pins are being aligned on there. So at this point, it's really important to use your tweezers and like really adjust so that you can get all four of those on there so that you can start starting the rest of them pretty easily. Yeah. So yeah, it's pretty straightforward. Then you just solder the rest of the pack. So. One thing that I think I'll cover this a little bit later, but when you're working with like larger devices with more pins, um, you want to kind of do it, you want to solder like not like sequentially, I think. You want to solder like diagonally or on another side of the pin, like for a pin on another side, so that it becomes more stable and you don't have all like the if you were to like bump your SMD component, you won't have all the force like on a couple of pins like right next to each other. I'll show that later too. But yeah.
So like with the micromouse MCU, you would probably want to solder a corner on each end first. That way, yeah, if you do bump it, you're not going to accidentally bend the pins and push it all out of place.
Yeah, exactly. So yeah, this is just like a really straightforward graphic about why you want to tin one pad versus tinning all the pads, so that when you slide your component on there, you won't have like an offset in the board, and it'll be a lot easier to solve.
Yes, the image on the left is called like it's mountaining sort of. Basically, you'd like to have the components flat because everyone knows, oh, it's harder for electricity to travel uphill, right? Yeah, not really, but
Okay.
you don't want to you don't want to tin all of the pads. That's basically what the wrong example is. You want to
Yeah.
tin one pad and then put the component down on it.
Yeah. All right, so here's some useful tips with soldering with an iron. Just like we said before, doing the initial joints is very important because then you don't have to localize um, all of the pressure onto one spot. So if you take a look, this is a MCU, and with all the pins on there, if you bump it, you're gonna rip off one of the pins. If you just do one corner and you just start from there. So that's a really good tip. And in addition, when you're doing soldering with the iron, it's really difficult to do with iron, so you want to use a lot of flux. And what flux does is, we went over this in the through-hole soldering workshop, but essentially it's the same thing here. Flux prevents oxidation of the melting solder so that you can get a clean joint instead of like something that's like really bubbly or like kind of dark to see like under a microscope. And then that weakens the joint and also it makes it a lot easier for solder to like uh, break off and yeah, just not be very stable. So one thing that you want to note is after using your flux, you want to be able to clean it, and so this can be done with like rubbing alcohol or some water. We'll go over that later too as well.
That being said, though, like,
Yeah,
don't be afraid to use too much flux because it's not really like it's going to hurt you, especially since when you actually solder the component on that has the flux will evaporate, so it will be gone after you've done it. Although there will be some residue left still, but it won't affect like circuit performance. It just might be sticky.
exactly. So yeah, here we see a very common mistake. So with the iron, it's like really small area to work with. So with the iron, a lot of times you'll get this common problem called bridging, or you just short a bunch of pins, and I've done that. And actually, it's um, a side note is sometimes it's good practice to um, short them all together, and then use a lot of flux to solder a lot of pins, and then later you go and individually um, take out the solder in between. But yeah, that's a side note. But for this point, if you run across a bridge where you kind of put too much solder, a really easy fix is to use solder wick. So from the through-hole soldering workshop, a lot of people are using like the solder remover or solder sucker, and a lot of times that's like really like forceful, especially with SMD components. So with solder wick, all you have to do is basically um, put the solder wick on top of the solder, and then put the iron on top of the solder wick, and kind of like make a sandwich. And then you just use like the flat side of the iron to heat up the solder wick, and then you can soak up um, all the solder. So it's just a really nice way to remove it. And I always use solder wick, so it's really
Wait,
nice.
Henry, can you go back one slide? I have
Yeah.
another note. So another way you could possibly do this would be to use basically the cleaning pads, the like gold Brillo pads that are inside those little cups to detain or to get all of the extra solder that's off of your iron. Place more flux on the actual bridge component, and then put your iron there to try and get some of
Oh,
that extra solder to go back onto the soldering iron, and then you can remove it again after
okay.
you've taken it off. And that should be a pretty easy debridging method as well.
Nice. Maybe we'll add a slide on there on the actual one. Just another method. So yeah. Solder works pretty reliable, and Evan said. All right, so we're kind of moving away from uh, soldering with the iron, and we're going to be using a different method. So the next two that we're going to be talking about is using the heat gun and or the oven. So those methods you would require the use of solder paste. And so here's a little bit of an info page on solder paste and like what that is. Essentially, it's the same thing. It's like solder except in the paste form, and on a microscopic level, it's in the form of really small balls, and they're typically graded by a bunch of types. So it's basically the size of the solder ball. I don't know. If you like look into a microscope, you can like look, and then you'll see the actual balls, which is really cool. But essentially, it's just a bunch of small solder balls that are inside of flux. So there's flux already inside of solder paste. And for storage, it'll be stored in low temperature, and then you'll have to clean it up. So yeah, it's the same material. It's just in a paste form.
There's also different types of solder paste that are made up of slightly different compositions. So you just have to be aware that like some of them will be maybe 63% lead and then 28 or 63% tin and 28% lead versus like 93% tin and 7% silver. They'll have different melting temperatures, which you have to take into account when you're using the heat gun as well as doing the PCB oven, because you'll
Yes.
need a higher temperature for things with higher melting points. So
Yeah, exactly. Nice. Yeah. So I guess you can introduce a little bit of soldering with the heat gun.
So the first step in this is basically you have to apply solder paste to basically all of the pads that you want to be using. Although for the heat gun, you'll probably want to try and do one component at a time. So basically you'll apply the the paste. So there's a variety of different tools to do this, although there's not that many in the lab. Usually you'll try and like, you can use sort of like a paintbrush, or even use the tips that come with the matter. Although a lot of times in industry, they'll actually print out basically these covers that will go on top of the board so that you can just lay across a whole entire wide thing of solder paste. So
Yeah,
basically it'll just be like a mask that you can put on that has
yeah,
holes for where all of the metal contacts are.
like a stencil. Yeah, and then you can just squeegee the solder paste on there, and then it'll be exactly where the pads are. It's really cool. But you probably have to, if you want to do that, you're gonna have to laser cut, or a lot of times when you're designing the PCB, you have to specify that the PCB manufacturer has to come up with the stencil. And so, yeah, just for the IEEE lab, I guess we're gonna be using the syringe, or just kind of manually putting on the solder. But yeah, and so after that, you're gonna apply, after you put on the solder paste, you're gonna apply heat in the oven. And yeah, so
Another potential option would just be to have a stencil that has specific package sizes on it that are useful to you, and maybe do it that
oh
way. That way you don't have to print out the whole entire thing.
yeah, that's right.
Okay, so these are the steps for using the reflow oven. It's super, super easy to use. Basically, you'll apply the solder paste like you did in the last method. So you'll use, a brush, the little tip. It'll form sort of like little balls, but you want to try and lay it flat on the pad. So then you'll place your components on the board, usually with your tweezers, and then all you have to do is just make sure the components are there on the right way. Then you'll select a temperature profile for the oven. For the oven in the lab, you'll want to run it through one test cycle so that it warms up on the inside, and then put the board in the oven, select the temperature profile you want, and then basically wait for it to be done. So there's a short little video in the next little 2 slides down, I think. No, it's the next one. That'll just show you some of the methods. Oh, that's super blurry. Okay, well, for our oven, there's 5 different buttons: F1, F2, F3, F4, and F5. Sorry, you can't really read this. There's also a video in the last section. This section is actually towards the end of that video.
Oh, okay. Yeah, so these buttons here, right?
Yeah. So basically, when
Um,
you turn the oven on, you'll want to, I believe it's press F3. Yeah, I cannot read that.
oh,
Well,
okay.
basically, the menu is sort of intuitive. You'll be able to select the temperature profile. It'll show on the display screen. There's also, in the manual, there's like recommended profiles for certain types of solder paste. So once you've selected the profile, you'll hit F4, and then F4 again, and then you'll press F1 once your board is in there, and it will go through the cycle. Once the oven is actually done, though, it will make this really loud beeping at you, and it won't turn off until you actually hit the stop button at the end, the S.
Yeah, so I think we can put like a step-by-step of what buttons to hit in order to choose your temperature profile, and then kind of like start the whole thing. But yeah, the manual also has really good documentation on that. And so,
It's
yeah,
the output, the menu is pretty self-explanatory because
yeah,
it has an option to choose. It has an option to do that, to actually execute, and then an option to make your own temperature profile as well. But you probably won't need that as much.
nice. Okay. Yeah, and so overall, the process I think takes about 8 to 10 minutes. So it's not a really long process, and all your parts should be really safe because it's about the same as like um, elongated time of using the iron. So yes.
Also, as it's going through the heating, it will show you the temperature profile that's actually going through on the screen. And you can see how it uses control processes to keep the temperature along where it should be in the profile. So if it's too cold, it'll turn on the oven to bring the temperature up. If it's too hot, it'll turn on the fan to cool it down a little bit. And yeah. So some other things to note is just the temperature profile depends on the solder paste that you're using. So usually, you'll probably want to select like the lowest temperature profile just to make sure like nothing on your board might get burned, since that was the temperature profile we actually tested with. But other than that, Yeah, we already said that the oven may need to go through a test cycle and that the cycle lasts approximately 8 to 10 minutes. So yeah.
It says 7. Maybe it's faster. Okay, nice. All right, so at the end, here's some like general reminders for using soldering inside the lab. And so in the lab, we'll provide a bunch of brass sponges, and you can use that to remove the solder so that solder doesn't oxidize on your tip. And then also, I guess in the lab, we do have a couple of different soldering irons with different tip sizes, although I'm not quite familiar which ones they are. There's just like really thin to really thick. And always make sure to stay safe with the fans to use proper ventilation. And then after you're done with SMD soldering your PCB, you can use rubbing alcohol or water depending on the type of flux that you have to clean it off. And then having a lot of patience and using a little bit of solder to go a long way is actually really key. So yeah, those are just some general reminders. Yeah. Okay. Rip. So if the project was in real person, we'd be introducing this board to you. And so what would be on the board is this really small PCB with a bunch of components that you can SMD solder. Oh, we have something in the chat. An officer can change the iron tip for you if you want to do SMD. Yes, exactly. Good point, Alex. Yeah, we do have various tips in the lab. So if you want to do like a wider solder, you don't want to use like a really narrow tip, we can change the tip for you. And so
the chisel tip works especially well if you're trying to do drag soldering. So basically, drag soldering is taking solder, dragging it across all of the pins that you have fluxed, but just using a little amount so that those pins, will get connected like that. It's a lot easier than using a thin tip to drag because it'll hold more solder too.
That's right. Yeah, so basically, I guess, yeah, if this project or if this workshop was in real person, we would be doing this project right now. Unfortunately, we won't be, but it's a really cool one, and hopefully we might be able to do maybe the next year's workshop, maybe do like a mini version of this project. And so, yeah, it's just to practice SMD soldering with like an LED and like a little timer, so that you can blink an LED on this really small PCB. Yeah.
It's basically the intro ops 555 timer blinking circuit, just with a battery attached to it. That's what the big metal contacts are on the ends.
A whopping 9-volt battery. All right. So yeah, that was a pretty short and straightforward lecture on SMD soldering. I guess if you have any questions, you can email Evan and I, or we can talk in the Slack chat with you. And I guess final notes is please stay safe during quarantine. And an fellow officer, actually shared this link for quarantine games, which is pretty cool. There's like Scuba Idler and stuff. So if you're bored, you can check those out. I'm sure many of the people in this workshop can attest to that. And this Zoom meeting will be uploaded onto YouTube, IEEE's YouTube channel actually, and that's pretty cool. And so make sure to like and subscribe to the IEEE channel. And yeah, and then here's some Zoom fails. Flaming hot Cheeto, you put that in.
What?
Oh
no,
no,
what?
Peter, oh no. Rest in peace. Wow, you're really flaming these officers here. No, they have some technical issues, SMH engineers. Okay, yeah. So moving on, I guess, Evan, do you want to introduce our next workshops?
Yeah, so basically next week we'll have a sort of another workshop that'll be rather short, that'll go into more advanced design concepts. So basically like, okay, like what are the best way to make your polygons? What are these like sort of heatsink things that we're told not to use, that sort of thing.
Yeah.
And then week 5, we'll do an LT Spice circuit design workshop. So LT Spice is just basically a circuit simulation software that helps you in making circuits, especially with analog components such as MOSFETs or BJT transistors. But yeah,
Yeah, so
those will also be recorded and uploaded as well.
exactly. Yeah, so look forward to some more workshops. We do have some more planned, and we're working on that. And there might be a couple of webinars actually from like ST Microelectronics who've reached out to us so that they have some like products that they want to share. So yeah, so keep posted for those. I think we could broadcast those through the IEEE email or on Facebook. And yeah, so there's a lot of other stuff coming out. So make sure to look out for them. But yeah, that's it for today, I guess. It's been a pretty short meeting, but yeah, thank you guys for showing up. That was actually pretty cool.